All right, thank you very much for coming to this session. I wanted to take this time today to introduce you to a few techniques that we use in prioritizing machine learning projects and how we scope them. This is not a coaching of what machine learning is, but I just wanted to build some context around, how to look at machine learning as an enabler for your business. Now, you saw a video of a lot of experiments that we do in Amazon. I know it's a productized video, but um, one true thing about Amazon is that AI is very normal for us. I know you might have seen this statement being put out there by a lot of people. You've probably seen this across different conferences. AI is the new normal. But for us, it has always been normal. It's probably one of the primary enablers for Amazon to deliver the experiences that we have been able to deliver consistently for our customers. We believe that AI needs to be normal also for our customers, and which is why we've been building consistently the AWS AI machine learning platform. Now, why is this statement made? I just wanted to build some economic quantitative context of why AI is the new normal. So, if we look at it from a market perspective, so in 2018, the estimated total productivity of the world, of all of the human race, was estimated to be about $80 trillion. Now, it sounds like a lot. It is a lot. That's everybody working together to build that much of economic productivity in the world. Now, that is only accelerating. So, we are expected to, in 2030, to create about $112 trillion worth of economic productivity in the next decade or so, in a year. So, this number is exciting, but the number that excites me further is this estimate by PwC that about 15.7 trillion of this economic growth is going to be powered by AI outcomes. So, well and truly speaking, about 14% of human productivity in 2030, so just about 10 years from now, is going to come from artificial intelligence based outcomes. Now, that is a big number because put it into context of .com and the internet, it's only attributed to about 6% of growth in human productivity. So the builders who embrace AI will truly be the engines of human acceleration. So now let's put into context what people say when they say AI. I know a lot of you are probably already familiar with this, but I just wanted to put some context around these terms and what people mean when they are talking about artificial intelligence. Now, if I look at the popular definition, if you go up, read up the source of all truth in the world, like Wikipedia or something, you'll see that when machines mimic cognitive functions, like which we associate with human beings, typically, we call it AI. So this is like things like problem solving and learning, etc. Any cognitive thing, any human brain-based thing, you typically popularly classify this as artificial intelligence. Now, this is not necessarily the mathematical definition of it, or the scientific definition of it. If you ask somebody who's actually a computer scientist or an artificial intelligence scientist, or what do they think, they're actually probably going to tell you something like this. So, artificial intelligence is the study of intelligent agents. Now, what is an intelligent agent? An intelligent agent is effectively any human-made agent that perceives the environment and then maximizes the chances of success at some defined goal. Now, the defined goal is extremely important, and I'll build some context around it. So, a good example of an intelligent agent is actually not too far away from here. It's the Deep Racer track and the Deep Racer unit that you will probably see at the expo here at Summit. Another example of reinforcement learning being used to build an intelligent agent-based driverless self-driving car system. Now, a few terms that you'll also probably hear quite a lot are data science, AI, machine learning versus deep learning. These terms are industry buzzwords. People use this all the time. I just wanted to put the context of how Amazon looks at it, and when I walk through this presentation today, of what do they really mean, at least to us. All right. Data science. This is the all-encompassing. I know it's a science, but it's actually an art as well. So, data science is the all-encompassing data profession that is becoming very and very popular. It has existed for a long time, and it encompasses things like machine learning. It encompasses things like big data processing, analytics, business intelligence, even reading spreadsheets. Anything to do with scientifically bringing out intelligence from data or processing data typically gets clubbed into data science. So it is the profession you hire for. All right. Now within that is artificial intelligence. Artificial intelligence is actually a pretty broad concept now. It's been like that for a while, primarily because of popular culture. Artificial intelligence, we've all seen movies of AI for a long time, and this has formed a lot of marketing around AI, and this is sort of now become a concept that is bigger than just machine learning or mathematics or just in database systems. So artificial intelligence is a broader marketing accepted concept which takes technologies like machine learning, it takes IoT, takes automation, robotics, etc. into one uber concept. Right? It's not something that is a skill that I can just go and learn, and it's not a single skill. Okay? Now within that, there is machine learning, and this is the area that is the primary enabler for artificial intelligence systems. So what is machine learning? Machine learning is the art or the field of programming systems without explicitly writing the deterministic rules of the system. So instead of building a completely deterministic rules-based application or a system, you are training an agent to perform the tasks in a probabilistic manner. So using probabilities and uncertainties to actually get to outcomes. Now within that, there is another concept, and probably one of the most hotly used words of today, deep learning. So when people say deep learning, what they're actually trying to refer to is a subset of machine learning, a subset of the algorithms that build all of machine learning. What is that subset? It's basically the algorithms that are built roughly inspired by the architecture of the human brain. Now, the human brain, actually, if you must already be familiar with this, is generally built of neurons, neurosynapses, and signals, electrical impulses going between neurons. So a human eye, for example, is about 1,000 by 1,000 matrix of optical cells. And the optic nerve is that, those about roughly 1 million cells going backwards into your brain. Now that is an example of a human neural network. The same thing done in an artificial computational context where you have nodes and then weights between those nodes that multiply the signals or reduce the signals across these nodes are generally classified as artificial neural networks. Hence, you get artificial intelligence, and that concept of putting layers of neurons, of one after the other. What happens when you get multiple layers of something? You get deep. So there's a lot of layers to deep things. That's why it's called deep learning. All right? Now, all of these terms actually mean something in a business context as well. And this is what our customers are now trying to do. So how to use data science, artificial intelligence, machine learning, and deep learning to build business outcomes. So I wanted to put this slide out there, which is what are the types of patterns of systems that our customers are actively building, and what is the type of business outcome they're looking for, so that you can probably think about what you might want to do as well. So any sort of typical machine learning based system, AI system, actually involves a cycle, a virtuous cycle of using some type of relevant data. This relevant data could be historical data, behavioral data, or actually simulation data or sensory real-time data. Okay? That, and then you apply some domain expertise. Like could be domain expertise of how to drive a car, domain expertise of what is fraud, what is not fraud, domain expertise of this object in a video is actually a lectern, this is a clicker, this is a screen. So those kind of things. So that is the domain expertise about the data to build some intelligent system or experiment. This intelligent system or experiment is typically a directional system. Data in, intelligence out. Data in, decisions out. And a lot of the times, data in, actions out. And these actions typically drive, or these recommendations or decisions typically drive, 5 patterns of solutions. If you have a system that needs to make multiple repeated decisions, a millions or billions volume or thousands volume, where you don't necessarily need a human being to do it every single time, or it's probably just economically unfeasible to do it with a human being every single time, like a fraud detection every time you swipe a card, like a recommendation every time you go and look up an e-commerce store. Those are perfect targets for automation, all right? So where you have similar types of decisions many number of times. So these are automating repeated decisions is a common pattern of usage of AI across our customer base in AWS. Now, the next type, where the decisions are not micro decisions, these are macro decisions. There's a lot of criticality or value associated to a single decision. Like when a pilot uses machine learning based signals that drive an outcome in terms of weather maps or to plan out the safe route of how to fly a large passenger airliner, they're making an assisted decision based on machine learning based signals. This is an example of the second type of system that people build. Now, the third type is actually very, very common. So this is when you're trying to build, forecast how much sales are going to be next year or next month, or how much more rainfall there is going to be. So basically, any measure of time versus value, a time series measure, how to forecast this, in the future, more time periods. So this is predicting future behavior is the third and actually pretty common type of machine learning based system that people build. The fourth one, actually, if you have established processes like a manufacturing process, like an approval process, like any kind of process that employs both human beings and machines today, where you want not just to know the outcome of the process. You kind of know this, all right? You already know the outcome of the process, or you are confident enough to predict what is going to happen, but you don't like what is going to happen. You want to change the outcome. It's not just about knowing what the outcome is going to be. I want to change the outcome. I'm going to change the question from, what is going to happen to how do I make X happen instead. And in that scenario, you actually analyze the data and actually put in some prescription of changing the process itself to get a different outcome. This is prescriptive analytics and process improvements using prescriptive machine learning based systems. Now, the second part, the part after that, actually, disruption. This is actually a perfect example is actually self-driving cars. A lot of our customers are building net new disruptive outcomes for their industry based on machine learning. Now, there's a lot of vision involved in here as well. So this is an area which is very subjective to the industry that you're in. So disrupting the industry. So these are roughly the 5 themes that we see across the board, across customers that are building these machine learning based systems. So depending on the type of data and the type of outcomes you're looking for, you can probably target in the vicinity of these 5. Now, our mission at AWS is to put machine learning in the hands of every developer. And we specifically truncate that at developer. And because we want to make sure that the systems that we build are not just for the seasoned data scientist or artificial intelligence researcher or somebody who has spent 10 years in that field. We also want to make sure that a developer who is net new to artificial intelligence and ML, who does not have a data science background, can still utilize the AI capabilities and embed AI into their systems as well. So the barrier of entry into AI is something that we want to make sure we democratize for everybody and we lower it as much as possible. And the system is built, and the systems that we build, the platform that we build for in AWS is designed to take care of that. Now, I want to give you a quick example of how machine learning has evolved our own Amazon business. So here's an example. This is actually an Amazon fulfillment center. So I'll let it play through a little bit. This is from a few years ago. As you can see, a fairly automated fulfillment mechanized center where people are actually taking items out of racks and putting them and picking them, etc. And you can see there's miles and miles of aisles and a lot of walking space, and these things get packed and automatically dispatched after that. Now, this is great, but what has machine learning done to this? This was a few years ago. Now, this is actually from not that long ago. This is actually a more automated, recent fulfillment center from Amazon. This is our Kiva Robotics division that has, instead of saying that people, the pickers, have to walk miles and miles and pick things and then put them in the bags and boxes, why don't we bring the aisles to the pickers themselves? All right. So this, because you don't no longer need aisles inside a fulfillment center, it gives us more than 50% more packing efficiency and operational efficiency without acquiring any more real estate. Now that is a major, major differentiator for us as a business, because we don't have to acquire more and more land or build more and more fulfillment centers, as the actual aisles are now coming to the pickers, and it's a fully automated operation. Now, this is not the only example. I wanted to give you another very simple example of how machine learning has changed our thinking as well. One of the very, very powerful examples of machine learning at Amazon, probably one of the things that built the ML DNA at Amazon, is the recommendations engine that you will see if you go to Amazon.com today. You put something in your cart, it recommends things that are related to it. Other people, when they're buying something similar to it. So based on transactional behavior and ratings, etc., you get different recommendations. Now, for a lot of people, that works. But there are a lot of people who are visual buyers. There are people in my own family who do not necessarily analyze or overanalyze like I do sometimes. They're not necessarily just going to buy because of reviews. So they want to arrive at buying outcomes or recommended outcomes in a visual manner. So this is something we introduced into Amazon last year, which is, if you go to Amazon.com and try it out right now, Amazon.com/scout. It's a completely image similarity algorithm-based, visual, computer vision-based recommendations platform that you can try out today. So a more store-like experience where you can go and buy visually. Now these are some, sort of disparate examples of machine learning systems that are powering Amazon today. We have thousands of engineers working on ML-based systems. But how and where do you start? So I just quickly wanted to walk through what are the sort of questions we ask ourselves when we try and prioritize these things. And I'm going to walk through a few of the mechanisms and share a few, not necessarily learnings, but few patterns that we found. So is machine learning, the important question to ask is, how and where do we start? And is machine learning really going to help you? And what does an experiment or a project look like? All right. So this has been something that in my job, I get to converse with thousands of customers on a daily basis, not in one day, but over the course of a long time. But as a result of that, one of the questions I get quite often, and our teams get quite often, is that, what does an experiment really look like? I'm not a machine learning company already. What is the first thing that I got to go and try and do? And the answer from us is always, we need to work backwards from a problem. All right. It's very it has been the culture of innovation at Amazon, where we always try and work backwards from a specific business problem. And that translation of a business outcome into a machine learning based data problem, and what the outcomes do and where do they meet really, is extremely important. Now, I'm going to share one of the mechanisms that we do, and I'm going to share it with you right now. So one of the things that helps us now in trying to scope out what a machine learning project for my company or for a certain customer is what we call the AWS ML Business Case Discovery Workshop. So we have to be very vigilant about how we scope an experiment, how we scope a problem, and how we visualize a solution, and how, most importantly, measure the outcome of a solution. What does success really even look like here? All right, and that forms a lot of our thinking. So we have to ask ourselves basically the hard questions early, because machine learning, the more you complicate your decision making in the beginning so that you have done your research in the beginning, the better the outcomes tend to be. All right, and a lot of customers tell us that doing this workshop with them actually helped them sort of scope the problem and then build a solution specific for that problem, and then show value and drive value for their customers very, very quickly. Now, what does this mechanism really contain? Basically, we're trying to understand the knowns and the unknowns. So when you're trying to devise the first machine learning project, or the second machine learning project, or the nth machine learning project, the first question we at Amazon we ask ourselves is this part of our DNA? You know, does this really map out to our vision? Our vision to be the most customer-centric company on earth? Does it really map to that? So every customer of ours, every user of AWS has their own vision. So it's very important that we have very strong early vision alignment of any project that we attempt. And then, do we have the domain skills to actually go and drive this particular outcome? Because it's not just the data scientist who solves a business outcome. A data scientist and a data professional and the data platform is only an enabler to a final business outcome. So it is extremely important to have the business and domain knowledge to apply to the data. Does this actually look like a fraudulent transaction? Does this customer's transactional pattern actually make sense? Is this recommendation of a video on Amazon Video a real thing? How do you get that reinforcement loop going of how to iteratively develop a solution? Extremely, extremely important. Now, our customers sometimes actually work in both B2B scenarios and B2C scenarios. This is actually an important question to ask yourself. Is my first project going to be in the B2B side, or is it going to be in the B2C side? Because typically, there's no right or wrong answer to this, but you may have better data on either side, or you may have a better chance of solving the first problem on either side. So that is an important question to ask. Which is it going to be an end customer facing solution, or is it going to be an internal B2B optimization solution? Important question to ask. We use that in our prioritization and thinking as well. The next part is problem definition. This is what I was talking to you about, so I don't want to go into too much detail, but saying, am I able to articulate the problem I'm trying to solve for in one concise sentence? All right? Being able to just articulate that, yes, I want to increase my overall sales in the year by driving down cost in acquisition of customer by X. Being able to put a concise definition to the problem and then concise definition to a potential solution is extremely important. And we do that in using that mechanism as well. And then prioritization. Hey, is it too important for me to deliver this 5 minutes ahead of my competitor, or is it more important for me it's okay to be late, but I want it to be super accurate? So prioritization of what outcome you're really looking for, because machine learning potentially can solve for either, but you need an optimization of outcome at some point. Now the next part is success definition. I always am extremely, extremely religious about making sure that this is defined when my team attempts projects. It is very easy for us to think about the vision and have a philosophical guess of what success looks like. Every company wants to have more revenue. Every company wants to have happier customers. Every company wants to have lower cost. So that is a very, very, overall Uber outcome of success. But Uber definition of success. But what we want to make sure is once we have that philosophical definition, hey, I want to increase customer satisfaction. I want to increase sales. I want to increase revenue. We have a numerical mapping of that definition. So what is the philosophical definition of success, and what is the numerical translation of this definition? So once we have that solidified, that helps us to say, hey, you know what? This is what numerically success is. Once we achieve this much of iterative improvement on what we are in today's baseline, then we can say that we have a successful experiment. Now, then you also got to define what the non-negotiables are. So it is very common, like, when we built Alexa, for example, we obviously had to go through this exercise of when do you release versus what quality of, what quality of utterances you want to be able to understand versus what level of extensibility you want to do on the platform. So what are the non-negotiables as a business that you want to deliver? And once you have that, are there existing targets that you need to meet? I know this may sound very basic, but it's extremely important to define early in the project. And we do that in every single one of our projects. Now, once you have the non-negotiables defined, next part comes to as you can see, it's actually step 2. Comes to understanding data, defining the experimentation environment, and then identifying the core team. So I'm just going to quickly walk through this. The first exercise is actually data inventory. I'm not talking about defining every single data point you have in the business, but saying once you've defined the problem, that actually builds the requirements of what data do you actually need to solve this problem. So having an inventory of existing data sources, they don't necessarily need to be in one place. They could be in many different places. Or defining what data is needed, saying, hey, I actually don't have the data in the right format or in the right location to actually solve the problem I'm trying to solve. So maybe the solution that I first built is a data aggregation or data acquisition and ingestion solution. So those are actually things and consideration points we have to make as a business. And I think you guys do this every day. And this is just something we need to lay out very, very quickly. Now, the next one is acquisition and annotation. I really quickly wanted to talk about that. I know I said it before. A lot of the times, customers tell us, hey, I have the data, but it's not ready for ML. Because I have a ton of images. I don't know if certain pixel is a face or an eye or whatever, right? I have a ton of transactions. I don't know if these are good transactions or these are fraudulent or not fraudulent. The time lapse between me having a transaction and me knowing whether a transaction is good or bad is too much. So we actually provide something called ground truth. I don't want to go into too much detail of that, but basically a framework which allows our customers and users of the Amazon machine learning stack to actually annotate the data that a machine learning algorithm can learn from. So saying that this is a good example, that is a bad example, this is option A, this is option B, this is great, this is bad. So annotation and acquisition is extremely important. Just once you know have the data inventory understanding, you'll realize what data you need and how you need it. The next part is security, and I don't want to go too much into detail, but it is shared responsibility. You have to understand that can you share the data with the party you're working with? What is the governance structure that you need to put in? What are the ethics concerns that the customer may have? And we have to be proactive about making sure that all of these things, from a compliance perspective, from a security perspective, from a customer experience perspective, are taken care of in the beginning. We know that this is what we want to deliver. We know that this is the customer experience, and we know that this is how we earn trust with our customers. And we have to make sure that this is a non-negotiable and taken care of in the beginning, so that later on, with a lot of investment into a project, we don't find a situation where we can't really do anything. And then, how will you experiment? Are you able to A/B test a solution? Can it run in a non-production environment? Can we define? Can we have decision pipelines which actually make these decisions? And then can we analyze these pipelines? Now, the next part is identifying the team. Make sure there's no right or wrong answer. I think my request to you is to make sure that a team is not just technical people. Not just the people who will build the solution, but the people who will use the solution, the people who will make decisions on the solution, and also the people who own the business outcome for the solution. So it is extremely important to have the domain experts and the resources and the actual owners of the outcome. I'll give you an example of what we do in a lot of business meetings at Amazon. Maybe you've heard this, we actually have an empty chair. Jeff, when he does these meetings, he actually keeps an empty chair, and that is to symbolize our customer in a business decision meeting. So what would a customer say if they were in this meeting? So it's extremely important to have all of the stakeholders of the outcome in when you're deciding what the core team is going to be. Now, I don't want to go too much into executive sponsorship. If you are the sponsoring executive, make sure that you define what a minimum viable product is. And I say minimum viable product and instead of a proof of concept, because these concepts generally work. Somebody else is actually using these concepts today. This is more about proof of value to you. What is the minimum viable product that you need to build utilizing machine learning? Now, and get the buy-in of the other sponsors as quickly as possible, and get them in giving you inputs about what solution they'd like to see. agree on the success metrics as quickly as possible and in as much detail as possible to say a 5% improvement may be great for a certain outcome, a 0.0005 improvement in, in click-through rates might be super important for a website. We never know. Agree on what is the defined numerical outcome you want to go after. And then once you have defined the MVP and defined the what are the targets, what the data sets are, that's when you go into the initial discovery. And then once your initial discovery is complete, then you go into a deep dive into the actual data sets to actually go and finalize the scope of what a first project is. And then the next step is when you go build. So this is specifically what we use as a mechanism. So I just quickly wanted to give you this. So take a few moments, take a photo of this, use a QR code. I wanted to open source our discovery framework. If you scan this QR code right now, you can actually download our own discovery framework mechanism as a document which has the questions that we typically ask ourselves. And then it also has sample answers for each of those questions. So it'll give you insight into the detail of how much level of analysis actually goes into prioritizing machine learning projects and building out a strategy for a project. All right. So feel free to take a scan of this, and it should lead you to download a discovery workshop document that we typically use. So you don't need Amazon to actually do this. You can do this with your own team. And once you realize that, hey, these are the knowns and the unknowns for a problem that I want to solve for my business, reach out to us. We'll help you build it. All right? And you can start building it yourself. All right. So now we wanted to use all of these techniques, and we set out to build a machine learning platform that is accessible to every developer, data scientist, and IT professional. And this is why I wanted to call out the platform a little bit. So basically, if you are a developer with no experience with machine learning, you can start off at the top. These are AI services where you don't necessarily need to be a data scientist. All you can do is go plug and play with APIs, which help you with vision-based scenarios, recognition, object detection, etc., facial recognition, etc., or speech-based scenarios like transcription, translation, or text-to-speech, etc., or language understanding-based scenarios like comprehension, entity extraction, and then chatbots and time series forecasting and recommendation engines. You actually don't need to be a data scientist. You can do plug and play with these resources that we built at that layer. Now, the next layer, if you are actually apt with Python, you know how to work with a Jupyter notebook environment. For those of you who are not familiar with Jupyter, Jupyter is a very popular IDE, which or integrated development environment for developers who use who do data analytics. Why Jupyter? It's actually Julia, Python, and R, so 3 languages together. So you can run those kernels typically. And we enable that through Amazon SageMaker, which is a fully end-to-end data science platform, from acquisition of data to streaming data to annotating data using the ground truth service to training to auto-scaling of the infrastructure to one-click deployment, to one-click publishing. And then once you published an endpoint, how to do traffic routing, A/B testing on that endpoint, and do continuous improvement and continuous delivery. All right? So that's the SageMaker platform. Now, if you are one of those people who have spent a lot of time, building machine learning systems on, right at the hardware level, right at the framework level, using MXNet, TensorFlow, PyTorch, Chainer, any of the machine learning frameworks that I've used multiple times in my own career, then we wanted to make sure that you have 100% availability of the most popular frameworks. So we do not pick a favorite. We have teams that build kernels and maintain kernels for all popular frameworks, and we provide a very wide array of hardware capacity around CPUs, GPUs, FPGAs, or even running it in containers or running models in non-connected environments. So the ability to put a model inside a drone or inside a car, which is not connected to the cloud. Now, machine learning is only a component, so make sure that when you are doing your frameworks or your discovery as an organization, you understand the full end-to-end nature of a full solution. So from ingestion to storage to compute to database to analysis to intelligence to the edge and inferencing, it's important that that you consider the full depth and breadth of the AWS platform. All right. Now, our customers are actively building a ton of machine learning systems, and just wanted to walk through a few of these. So, Too Simple is a Chinese startup that builds a completely autonomous truck that drives, across freeways and across roads, and it has a 1,000-meter advanced planning range system that actually plans out its route about a kilometer in advance with sensor fusion of LiDAR, short range, and long range cameras. The next one, we are working with Formula One. They utilize about 65 years worth of data to actually go and deliver, net new insights to their users and their drivers. And then Sunday Insurance in Thailand have built a completely AI-based, fully automated underwriting framework for insurance. They don't have any physical underwriters. Car sales are doing AI-based semantic segmentation of images. They are doing object identification, vehicle identification, fraud intent detection in queries, multiple different things. BGL Corporate are a software house that build fund management software. They built a completely AI-based transaction accuracy system, which is an assistant for fund managers in Australia. And I just quickly wanted to end with a video of the team at Redbus. Redbus, for those of you who aren't familiar, is a bus ticket booking platform started out of India and expanding across Southeast Asia. I wanted to finish with a video from Redbus.
This is Panish Guraj. I work as VP Engineering at Redbus.
I'm Puneet Karamba. I'm working as an engineering manager at Redbus.
Redbus is the largest bus booking platform in India. In terms of our pure bus booking volume, it can also be across the world. We are currently headquartered in Bangalore. We have other offices across the globe in Singapore, Malaysia, Indonesia, Peru, and Colombia. Redbus is a marketplace model. We have customers who want to hop onto a bus and they need an easy way of booking their bus journey. We also have the operators, which is a supply for us, who have a large fleet of buses on their side. At Redbus, we receive thousands of reviews, and we wanted to provide a better way to showcase these reviews to our end customers. The main architectural goals here was to provide these user-generated content in a much more simple way in terms of tags, so that he can make an informed decision. Secondly, we wanted to solve at scale because we have tons of data. Thirdly, we wanted to ensure that for different kinds of reviews, we wanted to have different variants, or in terms of modeling, like different machine learning models need to be available so that we can quickly iterate and give it to our end users.
Amazon SageMaker has been a revolutionary step in solving this problem, where we are able to save a lot of development time in terms of the issues which we had on our local machines, and porting that same thing to Amazon SageMaker has been helpful to do a lot of continuous iterations in training the model itself and evaluating the model. We have built this use case around scikit-learn, which comes within the framework of Amazon SageMaker. We have used the random forest classification algorithm to do our multi-label classification. We have hosted using the bring your own model technique of Amazon SageMaker.
The benefit of using AWS SageMaker has been, number one, conversion rate has improved by 5%. Our click-through rate has improved close to 20%. And finally, the time to go to market has actually reduced from a couple of months to almost a couple of weeks now. One of the business objective was to scale during a lot of our peak periods flawlessly, and AWS definitely has ensured that we are able to handle that well at scale. Redbus has been the earliest adopters of AWS in India. Just when the cloud was picking up, we made a good choice of getting onto the AWS platform. The plug-and-play architecture of AWS provides an innovative platform for the tech community to provide seamless user experiences. Almost all our workloads, both from development and entire production, work on AWS systems. We have been adapting to the latest offerings that are coming out there.
So with that, I wanted to thank you for your time. And there's a lot of ML that is happening across different customers on the AWS platform. And I really encourage you to go and do the discovery with your teams and try and understand the types of problems that you're trying to solve. And then come on to us, come on to AWS, and use the platform as quickly as possible to try and iterate and experiment on these solutions, because experimentation is a key to success in machine learning. Thank you very much.